All right, guys. So, do you have anything to say to all yourself? If you might be looking at this video at a later point in time, let me start off with Isaiah. Isaiah, you have anything to say to yourself if you're watching this video at a later point in time?
Stay off reels.
Okay, she, what about you? You have anything to tell yourself?
Honestly, do it for the plot.
Yeah. Sheena, what about you?
I don't know, lucky. I don't know.
Lucky, okay, okay. All right. I had to say something too. I don't know what to say. I have no idea what to say. Let me just begin. So a scalar. Do any of you all know what a scalar quantity is? Isaiah, I feel like I know you know what it is. So give Shea and Sheena a try. Also, because Shea and Sheena, both of you all have S's in your name, so I think you're supposed to know what a scalar quantity is.
A quantity that has magnitude and no direction.
Yeah. Do you want to be like a scalar quantity?
No.
No. You know why I say that? Because you need direction in your life. Right? Scalar quantities don't have any direction. So, Sheena, you told me what a scalar quantity is. So for instance, it would have a size, right? Like 5, 10, 11, 20. Okay. But it doesn't have direction. So it's only positive. Could you give me an example of something that's scalar? What is something that keeps on moving forward but can't go back? So that's what T. So it keeps on going forward but it doesn't ever go back. So that's what T. Play hangman. So that's what T.
Time.
Time, right? Time is an example of a scalar quantity. Do you all ever see minus 5 seconds on thing? I'll ever see that?
No, sir.
No, because it can't go back in time, right? Negative. Okay, so in all conventions, positive would mean that you're going to the right, and negative would mean that you're going to the left. So positive and negative just means you're going in opposite directions. Right? So an example of a scalar quantity is time. Shay, could you give me another example of a scalar quantity?
Mass?
Right? Isaiah, what's another example of a scalar quantity? I think Isaiah dog biting the mic. Isaiah, what's a scalar quantity?
Temperature.
Right? Actually, no, no. You could have negative 5 degrees Celsius or something. Yeah. Temperature is not a scalar quantity. So Isaiah, if something could be written as positive or negative, it's not a scalar quantity. A scalar quantity just has size. It doesn't have direction. So it's just positive. So time is incorrect. Shay, back to you. Any scalar quantities you could think of?
Volume?
Volume, yeah. And okay, I could tie in something we learned just the other day. Right? So Shay, if you want to find volume, wouldn't you have to multiply 3 dimensions by each other to get volume?
Yes.
Okay, so you understand that. So typically, volume would be, let me just use a cuboid for example. Length by width by height. Make perfect sense, right? What would the unit for this be?
Meters?
Meters what? You're multiplying meter by meter by meter.
So it'd be meters cubed.
Hey, Shay, you see how everything coming in into play? The maths, the add maths, the physics.
Yes.
Yeah, that about it. All right, so I want you to recognize something. Length, width, and height is what quantity? Is a fundamental quantity. What is it?
A fundamental quantity into derived quantity.
Yeah, meter cube is a derived quantity, right? But length, width, and height, they are fundamental quantities. And what's the fundamental quantity for them? This is a hint I'll give you.
Meters.
No, length.
Oh,
Length, right? You measure length in meters. So length is an example of a fundamental quantity, right? And let me ask you a question. So you ever see minus 5 meters? You ever see that in your life?
no.
No, so length is another example of a scalar quantity. And here what? So you understand that length is a fundamental quantity. So therefore, if you have something like volume, which is a derived quantity, it would also be scalar. You understand what I'm saying? So if length is a scalar quantity, then anything that has length in it would also be scalar. Make sense?
Yes.
So what do you think area would be? Do you think area would also be scalar?
Yes.
It would.
Speed?
Yes, speed. Do you think velocity is a scalar or a vector?
Um, I want to say vector, but I'm not sure.
Velocity is the same thing as speed, it's just a vector.
Oh,
Right. So let me look at vectors now. So we understand that, and the easiest way to remember a scalar is just it just has size as well. So scalars, just think of something that has no negative sign. No negative sign. If it has no negative sign, then it would have no direction. Right? Could somebody give me a couple of examples of vectors? Uh, to begin with, what exactly is a vector? Back to you, Sheena. What's a vector?
A quantity that has both direction and magnitude.
Right. And so think of something that is positive and negative at the same time. It can be positive or negative. So, Sheena, I believe Isaiah would have said an example, like temperature. And instead of like you could say 5 degrees Celsius, you could say 0 degrees Celsius, and then you could say negative 5 degrees Celsius.
Yes, sir.
Yeah, so that's an example of direction, right? Imagine you have a thermometer. You could either go in this direction or you could move down. So temperature, as you was telling me velocity. So velocity come like the twin brother of speed. So speed and velocity in maths, they use them interchangeably. When you all start doing kinematics like speed time graphs, you will also see it being called velocity time graphs. But in physics and art maths, there's a distinction. All right. Another example is acceleration.
wait.
With, I think the more accurate thing to say there is force. Force. Do you know that weight is an example of a force?
Yes.
Right. And the easiest way to know that is to look at the formulas. The formula for weight, right? Weight is equal to mass times gravity. And you know that?
Yes.
And what's the formula for force? I'll give you
Mass and acceleration.
nice. And gravity, the gravitational constant is actually acceleration. Because if it drops something on Earth, wouldn't it accelerate because of gravity?
Yes.
And so gravity is acceleration. So weight is equal to mass by gravity and force is equal to mass times acceleration. It's essentially the same formula. So weight is an example of a force. And let me ask you a question. Is a force could act in different directions?
Yes.
So it's a vector. It makes perfect sense. So we list enough examples. I think I'll have it down, right? So a scalar, a quantity that has magnitude but no direction. Vector is a quantity that has both magnitude and direction. So we have some examples here, or we went through that already, so I'm going to move on. Now we are going to look at parallel and anti-parallel vectors. So, I'd like you to read that for me.
The parallel and anti-parallel vectors.
Yeah.
We just add the vectors to form a single vector called a resultant. A single vector may also be the resultant of two other vectors. For example, an airplane's overall flight direction is a combination of the engine's Trust gravity and the wind. Opposite direction vectors antiparallel are viewed as negative. Draw the resultant vectors for the two examples below.
Okay, so let's just quickly go through this, right? So Isaiah, imagine, wait, right. So Isaiah, if you and your friend are pushing a box in the same direction, do you think that the forces would add together or subtract?
Add.
Add together. So it makes sense that if both of you all are pushing in what direction is this, left or right?
Very right.
That's it, right, okay? Then you would add the total forces so they would sum together. Makes sense, right? Shane, this obvious, like common sense. Yeah?
Yes, sir.
Okay, and obviously, if you and your friend are pushing something in the opposite direction, well, whoever is using the most force, that would it would result in the force going in that direction. So Shay and Shayna, which one of you guys, like which one of you all think is stronger? Like, I don't think I'll ever see each other like nothing but like if I had to see. Who will you think stronger? Like, Shay, do you think stronger? Do you think you're stronger or Shayna? Do you think you're stronger?
I don't know. People tell me I'm like kind of strong, but I don't know.
Shayna, you think you could take Shayna fight?
I don't fight for the trend, but
Say that again, Shayna.
I don't really fight for the trend, but I don't know.
That's good.
Who's
I'm
stronger?
not promoting that. I'm not promoting that. So, here what? Based on what Shayna said, we're gonna go, right? So Shayna wouldn't fight. So she will be the one bullying Shayna. Shay, stop,
What?
stop bullying people, Sharon. It's just a joke, right? It's just a joke, just a joke, right? So Shay, if you are the one that's exerting more force, wouldn't okay, so like imagine you guys are pushing each other. Shay, let me just say you're kind of immovable. And so Shayna is pushing you, so you're not moving, right? But if you push her and you push her with enough force that it allows her to move, wouldn't she end up going in the direction that you push her in?
Yes.
Because she's gonna have a force, right? Just by standing up there, her body is gonna exert a force. Weight, right? Weight, for instance, her weight is gonna act down, and that's gonna you'll have to apply a certain amount of force to push her in that direction. So what I'm saying is, as you can see here, we have a force of 4 newtons to the right and then 20 newtons to the left. Obviously, the final resultant force would be to the left direction. Pretty straightforward. Let's look at non-parallel vectors now. Did you all ever do something like this? Yeah or no?
No, sir.
Okay. Isaiah, what about you?
Yeah, yeah.
Yeah, okay. Shay, what about you? Did you do non-parallel vectors as yet?
I feel like I was probably introduced to it, but I want to say no.
No, okay. So let me ask you a question, right, Shay? Do these forces look like they parallel to each other?
No.
Matter of fact, what are they? They what?
Perpendicular to each other?
Right, they're perpendicular to each other. These two forces, they're not perpendicular, right?
No.
Okay. So let me show you how this is work out, right? All right, so I'm gonna show you all two approaches. So I'm gonna give you all an example, and then I am going to allow you all to copy it down. So let me take this question and we'll do this question together. Do any of you all know about the cosine rule? Yeah or no?
Me.
You? Okay. Word. So Isaiah, I'd like you to read this question.
An airplane is flying eastern still air at 92 meters per second. A heavy northeast wind starts to blow at 36 meters per second at 45 degrees. Using a scale of 1 cm to 10 meters per second, draw a vector diagram to show the resultant velocity on the plane. Measure the angle the plane deviated from its original path.
Okay. So here what I might blow some all your mind here, right? So here what we're gonna do. We are going to draw a scale down diagram. That's the first thing we're gonna do, and we're gonna measure the resultant. Then we're going to do the calculation and see by how much the answer varies. So we have, and before we do anything, right, all you had to know all your north, south, east, and west. So Isaiah, you think you know what your north, south, east, and west is?
It's in the middle of the top right box.
Wait, so this is north, this is south. What is this?
Was
Yeah. Ladies, any of you always have a hard time remembering where the like always mix up the west and the east?
No, sir.
Not really.
Okay. I used to have a hard time remembering it. And what eventually worked for me is I just remember it like north, we, s. We. Once you remember we, you can't mix it up. All right, the next thing you need to know is the general concept. So, Shay, it's really easy to understand vectors that parallel, right? Yeah?
Yes.
But when they're not parallel and they're perpendicular or there's some angle apart from each other, it's kind of different. So let's just say we had a force going in this direction and we had a force going in this direction. Intuitively and logically, Shay, actually, I'm gonna make it a little more common sense. So, like, make this force bigger. So, Shay, if you have something, imagine two people pulling on something, right? One person pulling it in this direction and one person pulling it in this direction. Say with me?
Yes.
Logically. And you could imagine that the final force on the object would be something like that.
Yes.
Okay, like somebody
In the middle.
yeah, somebody tugging something in this direction and somebody else tugging it in this direction. And some of this force would cancel off some of this force and it would end up going in the middle.
Yes.
That makes logical sense. And so how do we actually do it? Well, this is how we actually do it, right? So what I want you guys to, let me get my compass real quick. Let me get my compass. Do you all have a compass? I mean,
Yes, sir.
I just always mix up the names. If I'm a math teacher, I really shouldn't, but I just always mix up the name. Could somebody just remind me, is this a compass or a protractor?
I look, I forgot.
I think it's a projector.
Yeah, I think it's a
wait,
protractor.
yeah, I think.
The reason why I just always think it's a compass is because it have degrees and it's kind of look like a compass. I don't know why. I don't know who thought to call it a protractor. I really don't know. Like, what were they thinking? Let me just verify. So yes, this is a protractor. So this is what I'm going to do. I'm going to just do an example and you will copy down in the books after. So Shay, could you help me read this angle? This looks like how much degrees?
56 degrees.
Yeah, that looking like 56, right? So you need to measure the angle that's the angle between the two forces. So this is going to be 56 degrees. And then you're going to come to this end. You're going to come to this end. You're going to come to this end like so. I think you could visualize what I'm going to do. And I'm going to measure 56 on this end as well. You think you'd know how to do that?
Yeah.
Okay, so check this out, right? So I'm going to measure 56. Tell me when to stop, right?
Oh, sorry. Stop.
Okay, I'm going to stop over there. So, ladies and gents, all you understand what I just now do, right? So, like, I'll measure the angle between this force and this force, and I replicated it over here. So, let me just draw a dashed line. So, everybody understand what I just now do, right? No rocket science. Tell me.
Yes, sir.
Sheila, you understand what I just now do?
Yes, sir.
So, I just recreated 56 degrees on this end. Isaiah, your dog following along?
Yep.
Where's she gone?
She's square.
Okay, cool. And here we're gonna do, right? The next thing is you're going to measure the bottom line. So Isaiah, how much are looking like? Are looking like 5 point what?
5.4.
A little before 5.4.
5.35.
5.35, yeah. Matter of fact, you didn't even have to do that. Because when you draw this line, look what's gonna happen. You realize what's gonna happen, right? You see what happened? Isaiah?
No,
No? Okay, so the main thing is that you measure the correct angle between the two forces and you replicate it on this end. Once you do that, all you have to do is just draw a perfectly straight line and it would cut the line you drew previously and it should measure the same length as this length. So let's check if that's the case, Isaiah. We had measured the bottom length to be like 5.35. What is this length measuring? Check it out.
5.35.
Right. So once you draw the correct angle between the two forces on the other side, then it should work out. And so, ontologically, we said that the force would kind of be in the middle.
Yes.
Yeah, so the force would just be the,
Oh, more.
so this is the resultant. Yeah. And this is how you do it without any calculations. Yeah. It sounded like mind blowing. It was like, wow.
It's not quick.
But like you see, right? You know how we said it make intuitive sense that it would have been more to this side because this force is bigger. You can see it over here, because
Yeah.
like this angle here is smaller than this angle. Right. So that's how you would answer a question like this. So I want Ollie to take some time and just the heading I want you guys to put is non-parallel vectors. So put on the heading is non-parallel vectors. So Isaiah, you're perfectly fine with this, right? Non-parallel vectors.
Yep.
Shina, is there anything confusing you?
No.
Okay, good. And these are the kind of questions like that come for CXC. They like to bring this. Once they bring in forces, they go bring this. So since I'll show you guys how to do it, I think you should be able to handle the question fine. Let me just clean up the diagram. Right. So Shina, you can just walk me through these steps. Walk me through these steps.
Once you have your two force lines, you measure the angle with your protractor, and you basically mirror it on the next side.
Yeah, that's basically it, right? That's basically it. Excellent job.
Just the line on the bottom, and then your resultant is the line through the middle.
Yep. Right, and the proper name for that is the diagonal. Right? Great. So non-parallel vectors, finding the resultant. Mhm. Isaiah, you think you could tell me the cosine rule off the top of your head?
I think it's a squared equals b squared plus c squared. Subtract 2ac cos a.
Nice. 2BC cos A. 2BC cos. Yeah. Right, so here what's the main thing is I have the 56 degrees, right? The main thing is at the 56 degrees. So um let me just give a list of dimensions to work with. I realized I did not do that, so let me just do that quickly. So you could use a dimension here of 2 point, wait a, use 2.7. So use 2.7 and we'll call that newtons because we're primarily dealing with forces over here, right? So 2.7 newtons, and this would be 5.35 newtons. And guys, you need to put the arrows there. The arrows are very important because once you're dealing with vectors, you need to put arrows to signify direction. And so let's measure the magnitude of the resultant vector. Okay. I'm looking like 7.25. So when you'll finish draw this diagram, it's supposed to be like 7.25 centimeters. Yeah. All right, so as soon as you all are done with the diagram, you can send me a picture so I can see how it comes out. This is the time when it could be aesthetic, eh? Use some different colors on thing. So Sheena and Shay, they never do the cosine rule in trigonometry in maths, right? Like never.
We did trigonometry.
So you would have learned a squared is equal to b squared plus c squared minus 2bc cos a.
What?
That's the cosine rule, you know.
Hmm.
A squared is equal to b squared plus c squared minus 2bc cos a. You could think of it as a better version of Pythagoras theorem. Yeah. But you did that before?
Not that rule, but we did trigonometry.
Hmm. So you would have learned basic trig ratios like sine, cos, and tan.
Yeah.
Oh, okay. Well, you might get a little scared, but in physics, you just have to use the formula, which is not scary. But if you all had a prior understanding, it would have made it easier to explain. But that's okay. I will explain it from scratch. If I confuse all the other languages, just. Tell me. All right, so once you finish the diagram, just tell me, she now close to finishing.
Yes, sir.
Great. Okay, good job. Good job, Shay. Nice. And something to also do is see to the end of the resultant, put a arrow. This is the main arrow you need to have. This arrow, uh, this is the main one you need to have. This is the main one. Okay, good job, Isaiah. Just put the arrow to the end as well, right? And something you all should also do that I didn't specify, my bad. So, Shay, you see how you drew the diagram? You see that top line? You see the top line? I just changed to blue. Shay?
Hi.
Yeah, you see this top line here?
Yes.
This is not part of the actual diagram we'll get in the test, right? So if
Uh,
you're adding something, so we have to actually add it to the diagram. So if you're adding something to the diagram, ideally it should be light, or you should do this to distinguish it from not being part of the diagram. If you understand what I mean. Because
yes, sir.
this is the actual diagram you had to draw, and this would just be your working to find the resultant. Right? Okay, so we can move on, right? So now it's time for me to show you guys the formula. Try not to get scared. So the resultant would be equal. Here what? Since you never did the cosine rule, and she now as well. Since you all never did the cosine rule, would you all prefer if I just show you how to use it? Or show you the reason why we just use it as well? Or what do you all prefer?
I think show us how to use it.
Okay, I'll just show you how to use it, right? That's the most important thing. So the resultant would just be equal to the square root of, right? So I will just put on the formula and then I'll explain, right? So the resultant would just be equal to a squared plus b squared plus 2ab cos theta. So this is the resultant vector, or just a resultant force. There. A is just a force, right? So B is another force, right? And theta is the angle between two forces. All right, so that being said, let's apply the formula. So share A and B in this question this would be A and this would be B, right? So A and B are just the forces, the two forces you're dealing with. Understand?
Yes.
So let me use the formula, right? So that's going to be R. So R is going to be equal to the square root. So A is 2.7 in this diagram. So 2.7 squared plus 5.35 squared plus 2 by 2.7 by 5.35. And what is the angle between the two forces, Shana? What is the angle between the two forces?
56.
Right. So I want you all to plug that into the calculator, and you know what you're supposed to get. Like we're expecting to get something close to 7.25, right? If you have a Sharp, good luck. If you have a Casio, real easy. Just to confirm, everybody here have a Casio, right?
Yes, sir.
And Isaiah, yeah, you have a Casio, right? Okay, nice. All right, so anybody get something close to 7.25?
I got 7.21.
What you got?
7.21.
You don't think that's crazy? Like, obviously we measure it, right? We do a kind of we didn't actually like we kind of round off when he was measuring, right? You don't think that's crazy? Like how close it is? It can't more than cool, right?
Yes, sir.
Yeah. 7.21. She. You get something very close to 7.25? She.
Oh, so 7.21. I was just making sure.
What did you get?
I also got 7.21.
Great. I mean, you're supposed to get the same answer, right? So great. Great. So yeah, she like, what do you think about it? Cool?
Very convenient.
You're not the whole diagram or just use the calculator, just use the method, just use the cosine vectors.
Yeah, the cosine.
Yeah. Right? And we call this the parallelogram law of vector addition. Right? So this is what we call this. Parallelogram. Right. Isaiah, I presume you don't know this?
No,
Oh, you didn't know this?
no.
Yeah, well, okay. Well, I guess you're learning some new stuff then. That's good. Right. Great. So I showed you guys the two methods. Now in school, they don't really show you the formula part. I don't know why. When I was in school, my teacher would have shown me both. So yeah, I think it's convenient to know both. Right. So once you have this note copied down about parallelogram law of vector addition, I will give you all 10 minutes to try the question. using both methods, and you should get about the same answer when you do both methods. Which one do you think is more accurate? Drawing the diagram or using the formula?
Using the formula.
Yeah. But if you take wrong measurements, which one will be more accurate? If you take wrong measurements and you plug it into the formula, which one will be more accurate?
None, I think both would be wrong.
They both could be wrong, right? Well, I think this would be like how you go and look at this and measure this wrong. That is what I can't put it past some people. I can't do that. Some people might measure it like this. They might start at one instead of zero. I don't know how. I've seen some things in my days, and I've done some crazy things myself. Yeah. Or they ever find like all your old standard 5 book or standard 4 book and see what they used to write. That's a very humbling experience. I would advise you all to look back on old notes. Right, so does everybody have it copied down?
Yes, sir.
All they had to tell me, she, I can't read no minds. She, Isaiah. I had to tell me. Oh, Isaiah,
Yes, sir.
Isaiah, did you copy down the parallelogram law of vector addition?
Yeah.
Yeah, okay, cool. So 10 minutes on the clock. I'd like you all to try the question. I giving all this so much time because you had to draw the diagram, you had to measure, and plus you're using the formula as well. So 10 minutes. Are you all seeing the whole question or is anything blocking us?
See new question.
Okay, cool. Good. Imagine getting a question in physics wrong because you don't know north, south, east, and west. That would be hilarious. I make that mistake before. Yeah. She would you do that?
I don't like geography, but I don't think I will.
Okay, well that's great. It's a good thing I didn't do the cosine rulers yet because the cosine ruler in maths is a squared. Okay, so I don't know if I should say this because it might confuse you, but like in maths is c squared is equal to a squared plus b squared minus 2bc equals a. But over here is plus 2ab equals theta because you have to rearrange and make things the subject of the formula and it's a proof. So it's not as straightforward. So yeah, I just think it make more sense if I just show you the formula and I use it. When that time come in maths, I will explain it in terms of physics as well. Did any of you all get some answers yet?
No,
Yeah? Shit not. You say yeah?
so I say no, sir.
Nah? Okay. Something I should mention, right? When you get your final answer, just know that you would have to scale it back up. So, Shayna, for instance, they said use a scale of 1 centimeter to 10 meters per second. So, by the way, um, they are talking about velocity here, right? Velocity and speed is the same thing, but in physics, we mostly use velocity. So, Shayna, so they're saying an airplane is flying east, right? East. So, that line, what would be the length for that line? If they're saying 1 centimeter to 10 meters per second, what would the length be for that line that going in the east direction,
9.2.
right? And the other one going in northeast would be 36 meters per second at 45 degrees. The length for that would be
3.6.
right. Yeah, guys, so how things going now? Isaiah and Shay, are y'all getting through?
Yeah.
Yes, sir.
Yeah, okay, cool. So Shay, like, if it was up to you, right, you'd have just use the formula and done. Because
Yeah.
you had to figure out how the diagram gonna be drawn and how it's gonna look and all that. You use the diagram will tell you one time what the answer is.
Can I see my answer?
Um, Isaiah, let me see what you sent. Yeah, excellent job there, Isaiah. Excellent. All right, so Isaiah, something I want to tell you, right? Um, I would like you to put the head of the. Okay, so this will be the tail and this will be the head. You have to put the head at the like the end point. So don't put the head over here. Like put it at the end point. This is kind of an exception, but you still need to put it at the end point. Still need to put it at the end point.
Good.
The reason why we typically put it over here is because when you have all of this drawn, it's gonna be hard to see it over here, but you should still put it over here. All right, so in your diagram, make sure you put it at the end point of those two vectors. This is some advice. Oh, shit. Something to keep in mind, right? Um, that's so like, okay, you see that I have newtons in the question. Did you see them mention newtons? Mark said that. So, did you see that they mention newtons anywhere? So, she read the question. So, you make two mistakes. I'll go it over with you, right? Number one, the units for this particular question was meters per second, so not newtons. Number two, shape. If you draw a scale down diagram, a scale down version, then to get back the actual value, what would you have to do at the end?
Convert it back to the original thing.
Right. So if 1 centimeter is 10 meters per second, then you'd have to convert that back. So you'd have to multiply that by 10. In the resultant formula, you wouldn't put 3.6 something. You would in the formula, you would just simply put 92 and 36. You wouldn't put the 3.6 and the 9.2. You understand why, right? Because if you use any formula, you don't need to use our scale. Understand?
So
Yeah, so if you use any formula, there's no need to use our scale. So let's do the question now. Shayna, I don't think I got a.
So I
Yeah.
sent it to you.
Oh, you sent it? Okay, I didn't look at it. My bad. Let me check it out.
So actually, I made the same error with the Newtons, but I fix it in my book now.
Okay, good. And you didn't make the mistake with the resultant. When you find any resultant using the parallelogram law of vectors, aka the cosine rule, you don't put the scale. You don't put the scale down version. You just put 36 and 92. Nice. So Shay, let me speed through it fast now. So they're saying it flying east at 92 meters per second. So we're gonna divide that by two, and that's gonna be 9.2, right?
Yes.
Right, 9.2. By the way, I'm not sure if you ever got this, right? But obviously, you know theta, right?
Theta,
Theta.
like the angle thing.
No, no, no. Auntie, your mom and Shweta's mom is friends. I'm not sure if you know Shweta. Babulal.
I think you should ask her. I don't really know.
But you don't really know her.
No.
Okay, because you all answer questions in a very similar manner. Like how you all say stuff is very similar.
Oh, yeah, I don't know who that is.
Okay. I think I think it was your mom that knew who the person was, not necessarily you. All right, so yeah, we drew the first vector, right? Cool. Help me with the second one. They are saying northeast, but we could ignore that, right? We're just looking for the 45 degrees, and yeah, this is not geography, this is physics. So I'm gonna put on the 45 degrees right here. And before I do that, Isaiah, what length should I measure?
3.6.
Should measure 3.6, right? So 45, 3.6, okay. Oh, past 3.6. That's as good as I am going to get it. Right? And since I have the angle here one time, let me just do the 3.6. Right? Cool. Right? You need to put the arrow at the end of the vector, right? The resultant would be over here. It's just a diagonal. Okay. So Shay, you see how much headache it is to do the diagram? Do you
Yeah.
think it's worth it? I
If I
don't.
get a max for it.
Well, if you get marks for it, if you could avoid it, by all means avoid it. Right? Shayna, which one you prefer to do, the formula or the diagram?
The formula.
Yeah. Well, if you don't remember the formula, well, you gotta do this. Right, so make sure your diagram looks like this. If you want, you could leave out this arrow. The main arrow that you need to have for all of them is the arrow needs to be at the end of the vector, right? But again, the reason why we put the arrow in the middle is because it kind of hard, like in the exam, right? You're only gonna have one color, right? You're only gonna have one color, it's a pen, so it's gonna be kind of hard to see over there. So pay it over there to show the direction. Great. So let me just measure this quickly. Right, so Isaiah, you'll just measure this one. So right there. Yeah, what are we looking like?
12.45.
Okay, 12.45. So everybody's diagram is going to be different, right? Just keep that in mind. Right? And I'm going to put, right? This is going to be 9.2. Right. Okay. And so resultant, so therefore the resultant will be equal to 12.45 meters per second multiplied by 10, and that would be equal to 124.5 meters per second. But I want you all to realize something. What did they actually ask you to do in the question? Shay, read that. Read that from me.
Measure the angle the plane deviated from its original position.
Where do you think the angle would be?
Um, like in between the line and the straight across line.
Yeah. So let's take that measurement. So let me see what they got in this diagram. In this diagram, okay, they just said 12 to 13. And so we was fairly close, right? And angle 10 to 12. So let's see if we'll get that. Okay, well, what are we getting? Tell me, Shay. What are we getting? What are we looking at?
10.
They're looking like exactly like 10. I want Shina, I want you to measure it in your diagram and tell me what you're getting. Are you getting 10 or something different? I suspect that you all will get something a little more than 10 or a little less.
10.2.
Okay. So obviously the answer is going to be different. Just mentally prepare yourself for that. Right? Mentally prepare yourself for that. Right? And angle angle of deviation. Right, let's use the formula quickly. So Shina, could you call out the formula for parallelogram law vectors? So R would be equal to
Oh, sorry, the resultant. Well, oh, sorry. A squared plus B squared plus 2AB cosine and the angle between two forces was 45.
right. And so I'm gonna say 36 squared plus 92 squared plus 2 by 36 by 92 cos 45. Isaiah, what was the answer you got to two decimal places, please?
It
Actually,
was 120
actually,
points. Yeah.
actually, just give me the answer to one decimal place. In physics, you look at
Yeah.
the trends of the question, right? In this question, 3.6, 9.2. So give your answer to one decimal place. So yeah,
It was 120.2 meters per second.
120.2. Ladies,
Yes.
you all get that? 120.2.
Yes, sir.
Okay, cool. Now, let's find the actual angle, shall we? Let's find the actual angle. Now, all of you guys are AdMath students, so I am expecting a little bit more from you, right? So let's try to make theta the subject of the formula. Actually, yeah, excited for that. We're gonna try to make theta the subject of the formula.
I don't know.
Actually, nah, I wouldn't put a little through that. That might take up a little while. Okay, so the point is, I didn't know how to draw it, and I didn't know the parallelogram law of vectors, right? Cool. Yeah, we good?
Yes, sir.
Cool. So we okay with vectors. All right, let's look at mass and weight now. So let me ask a question, right? If I were to see 50 kg, is this mass or is this weight? What do you all think? Is 50 kilograms mass or weight?
Mass.
She agree?
I think weight, but I think I'm wrong.
Okay, she, what's up? Why instantly wrong? Let me show you.
Because it's a fundamental quantity. Well,
That's no why. Okay, so I mean, yeah, if you remember the fundamental quantities, you remember that kg was one of the units for the fundamental quantities, and that would correspond to mass, right? But how I like to tell my students is, okay, think about it like this. When you think of weight, right? Hey, oh, you know who Gabi Faye is?
Huh.
Yes.
Shayna, you know who Gabi Faye is, right?
Mm-hmm.
And Shay, you know who that is?
no.
That's the one that on the grave, defecated on.
Oh, yeah. Oh,
So she real big, right? Now imagine if she sit down on you, right? Or imagine if somebody that on the kind of fatty, they sit down on you. Or imagine you're on a seesaw, right? And yeah, so your friend or whoever on the seesaw, they're real kind of fatty now, they're real chubby. Um, because of their mass, here is right. Because of their size, right? Um, if they sit down, wouldn't their body exert a force, a downwards force? Yeah or no?
yes.
So like, all I ever hear is saying like, oh gosh, again way down, something weighing me down. It's like I feel a force on me, that real weighing me down. You ever hear that?
Yes, sir.
Yeah.
Okay, so if by that logic, right, weighing me down, and I needs to say that again, it weighing me down. Here the context of the thing, It weighing me down. What do you think that is? That sounds like a force. Doesn't that sound like a force?
Yes.
If somebody sit down on
Yes, sir.
if somebody sits down on something, because of the mass, the amount of matter in their body, it will exert a force because of gravity on an object. So anytime you hear weight or weigh, you should already know that's a force. And I trust that everybody here knows what the unit for force is. Shay, do you know what the unit for force is? I see
Newtons.
Newtons. So here what I'm saying, right? If you know that weight is a force, then weight's supposed to be measured in what? If weight is a force, and we know what forces are measured in, what is weight?
Newtons.
Right. So when you look at this, it's supposed to scratch off weight from your checklist because you see in kilograms there. Understand?
Yes.
Yeah. So Shayna, Isaiah, if all you see kilograms, please don't make that mistake. We know that weight is a force. Weight is a force. From me saying, oh gosh, that real weighing me down. Weighing down, weight is a force. Measured in newtons. Kg is mass. And again, mass is just the amount of matter in a body. Right? Weight is the force exerted on an object by virtue of gravity. and the object's mass. Hence, you know, mass is like weight is equal to mass times gravity. Mass would be equal to weight over gravity. Yeah. Right. So I think you all need to copy this down. Not necessarily the example, but I want you all to copy down mass and weight. Copy down mass and weight. If you can't mess this up, please. You can't mess this up. Right? And mass is measured in kg. So you put a little kg in brackets. And weight is in newtons. Right? Because weight is a force. So Shay, are you ever going to mix up the two again?
Oh no, I don't think so.
Wait, ask her. Would you ever mix it up again?
No.
No? Good. Right? And Shayna, if you ever had a hard time remembering or distinguishing, now you know, just always remember weight is a force. So newtons. Isaiah, you ever mix up mass and weight
In Form 3.
in form three? Not again, right?
No.
I used to mix it up as well. I don't know why. It's only when I realized weight is a force, then I stopped mixing it up. Like weight, force, newtons. So kilograms had to be mass. Right, so guys, just please tell me when you finish copying down the definition for mass and weight. I I don't want it to have more weight in here. You know what? Just not do that. Yeah.
I finished copying it down.
Okay, cool. Isaiah and Sheena, I they know how to copy down the example, That will take a little while. Just copy down quantity and definition. Um, She, while we're on the topic of weight, weight is influenced by gravity. So do you think somebody would weigh the same on Earth versus on Jupiter?
No.
Huh?
No.
Nah. Would their mass remain the same?
Yep.
Yeah, because it's the amount of matter they have in the body. The matter isn't going to change. All right, so I'm going to move on, all right? All right, so you need to know the formula for weight. Weight is equal to mass times gravity, and that formula comes from, let me show you where this formula comes from. I would have explained it previously. This formula comes from F is equal to ma, right? And Shay, why does this formula come from this? Because weight is a what? What is weight?
Weight is mass times gravity and force is the same thing. Weight and force is the same thing.
I wanted to hear that weight is an example of a force, but yeah, that's the real reason why, because weight is a force, so that's why we just use the same formula. So you all could copy this down, right? You need to know the formula for weight. Yeah, again, so as soon as you have that copy down, tell them fast, right? right, so we have that copy down.
Yes, sir.
Yeah, okay. Did you all copy down that W is weight, M is mass, G is acceleration due to gravity?
Yes, sir.
Okay, good job, Sheena. Isaiah, what about you?
Yeah.
And Shay, you too?
Yes.
Okay. Before we move on to center of gravity, right? Just a common sense question. Which object do you think would have greater, a greater stability? A very tall object or a very short object? Which one will be more stable in the event of an earthquake?
A short object.
Do you know why? It makes logical sense, right? But do you know why? Shay, do you know why? Isaiah?
Because its center of gravity is closer to the ground.
Yes. Shay, were you going to say that?
I was gonna ask you to repeat the question.
Oh, so Shay, in the event of an earthquake, which one would have a lower chance of toppling? Oh, okay, let me repeat it again. So you have an earthquake, right? You have a tall building and you have a shorter building. Which one would topple over quicker?
I feel like the taller one.
You think the smaller one will topple over quicker?
No, the taller.
The taller one, and yeah. Think about it like this. And tell you this play Jenga. I've never played Jenga before.
Yes.
Yes, sir.
You know, like coming down to the end, it'll start to topple over because you're removing support. And so it come like, I know it's staying the same height, but you're removing the support. And so it come like you're going, I really don't know how to explain it, but and when you remove pieces, it starts to lose stability. In Jenga,
Yes, sir.
yeah, when you remove pieces, it's lose stability. Another example is like, are there of us like, I don't know, are there of us stack things before, like stack Legos or um like dominoes or I don't know. I don't know if I ever do that.
Yes, sir.
Yeah, because like I know that's like a old people thing, like because like kids these days never do that. Like, Shay, you ever stack anything before?
All the time.
Like what?
Books, everything.
Like, okay, so like if you keep stacking books, eventually the stability will diminish and the books might topple over. Cool.
Yes.
So objects balance at a point called the center of gravity. And let me explain that, right? If, okay, when you're bored in class, any of you guys ever try to balance a pencil?
Yes.
Okay. Isaiah, you ever try to do that? Balance a pencil?
Yeah.
Okay. And usually, where do you land on? The center, right? Yeah or no?
Hmm?
Shayna, when you balance pencil, right? And you usually end up with the pencil and your finger being in the middle of the pencil.
Yes, sir.
Yes.
Okay, and let me go through some logical things again. If you want to hold up something, and you have to hold up the weight of the object,
Yes.
Yes, sir.
and so if you balancing your pencil on your finger, then that means you are holding up the entire weight of the pencil. So you see in red there, the point at which the weight of a body acts. So that's the center of gravity. So when you find the center of gravity, that is where all the weight of the pencil is acting. And once you support it, it would stay up. It would stay in equilibrium. So I would like you all to copy down this note over here. So a lot of things in physics just make sense. It's just common sense, I think. Because Sheena, if you're not holding up all of the weight for an object, when the object fall down,
Yes, sir.
yeah, exactly. So at the center of gravity, all of the weight is acting. And if you support it at that point, it will stay up. So Shay, we prefer? You prefer chemistry or physics?
Chemistry.
What? You serious? What physics?
With chemistry, you can make a bomb.
Make it out physics too. Wait till we start nuclear physics.
Yeah, I like chemicals.
Okay.
I
Okay.
ate the chemical in the lab, so I enjoy doing that.
What? I don't think that's something to be bragging about. Next thing you say, I sniffed, you know, in the lab, Breaking Bad. I don't think you should be saying them thing on video. Next thing, a couple of years, you get accused of drug trafficking and they find this video and they hear, hey, and they hear she saying, oh my God, I eat something in the lab. You get incriminated fast, boy. Hmm. By out of curiosity though, what did you eat from the lab?
I think it was calcium something. Calcium permanganate or something.
Yeah. Isaiah, you ever do that madness before?
No.
Shayna, what about you?
No, sir.
Shay, alone on this one. Yeah, alone.
Oh, we were bored and we were waiting so long.
And the worst I do was I carry home some stuff to make a bomb.
That's worse.
No, it's like a stink bomb. It's not like an actual bomb that's blow up. Yeah. It's not that bad. It's not that deep. Yeah. If it was like a combustible bomb, well, that was for
I
sure.
hate the tap.
You hear the what?
I hate the taps, the taps in the lab.
Yeah, like the burettes and the pipettes and yeah,
Yeah,
man.
I hate the taps. They're so aggressive.
Oh, talking about like the taps to
The
wash.
water pressure.
Oh, okay, okay.
Yeah.
Oh, yeah. I guess that's a thing in all schools, right? So as soon as you all have this copy down, you'll tell me, right?
I'm done, sir.
You done? Okay. Nice job, Sheena. Also, Sheena, what you prefer, chemistry or physics?
Chemistry.
What? Isaiah, I guess we are alone on this one. Isaiah leaving more way by Isaiah. I say it was on
Physics is food.
yeah, physics is food. Physics is cheesecake. Okay, so I'm going to scroll down, right? I presume everybody have this copy down. So the takeaway is that at the center of gravity, all of the weight acts. That's what you have to keep in mind. And you should also know that if the center of gravity is located higher up, the stability decreases, right? So objects, why reading for? Isaiah, I want you to read. I never hear you read before. Objects or systems, read that part. Yeah, Isaiah, objects or systems.
Objects or systems that are stable tend to have more of their mass deposited much slower than the unstable ones. They are said to have a low center of gravity.
Okay, right? So ladies, again, this is common sense, right? If you have a tall building, it would have it would have less stability compared to a shorter building. Are you understand?
Yes.
Yeah. Cool. Right. And so we have you have to know three types of equilibrium in CSEC physics. Stable equilibrium, unstable equilibrium, and neutral equilibrium. So let's distinguish between them. So Shay, if you have something with a low center of gravity, and you would describe it as being stable, yeah or no?
Yes.
You see that kind of
Yes.
let me give you an example, right? Okay, let me just say you stack Legos, right? And the Legos is 1 meter high. You think they're very stable?
No.
No. What about compare that to something that's like 10 centimeters? You stack Legos and it's 10 centimeters. Which one more stable?
The 10 centimeters.
And which one would have a lower center of gravity?
Uh, the meter.
Nah. the center of gravity would be kind of high up. 10 centimeter would be like at 5 centimeters. Let me give you, I want to make sure you understand that, right? So let me just reiterate that. Think of the example with the pencil, right? And the center of gravity will usually be in the center of the pencil.
Yes.
Okay, so if you stack Legos and it's 10 centimeters, provided that all of them weigh in the same mass, what's saying weigh in the same mass? All of them have the same weight, right? Presuming that all of them have the same weight, the Lego blocks, then the center of gravity for this would be in the center, obviously. And so that would be, the center of gravity here would be at 5 centimeters. Make sense?
Yeah.
Okay, you stack it up to 1 meter now. Right? So, mark Shayna this. Shayna, we stack it up to 1 meter now. Again, provided that all the Lego blocks have the same weight and a uniform, the center of gravity here would be 50, no, it'd be 50 centimeters from the ground. So which one has a lower center of gravity? The 10 centimeters or the 1 meter?
The 10 centimeters.
Exactly. Shay, you could see it, right? This one is over here, and this one is over here.
Yes.
And so we see an object has stable equilibrium when it has a very low center of gravity because there's a low chance of it toppling over.
Oh. Oh, that makes sense. That makes sense.
If it's unstable equilibrium, so let me give you an example of this, right? So again, side quests. You're feeling bored, you decide to play flip in the bottle. All you ever flip the bottle, and the bottle land in a very awkward position, but it stayed there for a bit. Yeah or no? I don't know if you know about flipping the bottle. Again, that's like
Like a bottle flip.
all you ever do that? Shina, Isaiah, all you ever flip the bottle?
Yes, sir.
I had to test the waters, all you young. Isaiah, you ever?
Yeah.
Okay, good. So like, all you know what I'm talking about then. Any of you guys ever got it to land at on the bottle cap?
Yes.
Okay, you're bad.
Yeah.
Let me ask you a question. If it land on the bottle cap, do you think it is stable or unstable?
Unstable.
Yeah, because a little hard wind blow, somebody, I was going to say a joke here, but I want to hear the joke.
Yes.
Let me just say one of your partner bust a fart, that bottle going to fly down, you know what I mean? So, I don't understand what I'm saying, right? If something is, okay, so if you flip the bottle and it lands at a base, then it's stable, right? Right, Shana? If you flip
Yes, sir.
and it lands on the base, it's stable. If it lands on the cap, you'd say unstable equilibrium. It might stay there for a couple seconds, but it will fall on eventually, right? So it has a high center of gravity and neutral equilibrium. Example of neutral equilibrium is a ball. Isaiah, if you hit a ball, right, and the ball would move forward, it would roll.
Yeah.
It would roll, right? And it would eventually it would eventually stay like okay because of friction and all that, wouldn't the ball eventually stop?
Yeah.
Right, the ball would stop. But you understand that, okay, if it's neutral, that means if you apply a force, it will just move. So Isaiah, think of it like this. Stable equilibrium means that it's stable. It's stable, right? It would stay there. Okay, Isaiah, you with me? I'll wait to stay unmuted for this one. And ladies, listen up. This is the common sense explanation. So Isaiah, if you have something in stable equilibrium, it would stay there, right?
Yeah.
If you hit it, it might probably stay there. Unstable equilibrium. If you hit it and take a move and take a fall down,
Mm.
it's very easy to fall down. Unstable equilibrium makes sense. Neutral equilibrium, no. Neutral equilibrium, it kind of in the middle. It's neutral. If you apply a force, it will just move, and eventually it will stay there until you act on it again. So these are the things you need to know. Stable, unstable, and neutral. Stable equilibrium has a low center of gravity. Unstable equilibrium, a high center of gravity because it's unstable. And for neutral, the center of gravity doesn't change. Shay, if you roll a pool ball Does the center of the pool ball ever change?
No.
No. So, and I'm asking a question. And if you hit a pool ball, it would just start to roll.
Yes.
Does it resist you? Does it resist the force?
No, unless it's friction.
Yeah, unless it have friction. So you understand why we call it neutral, right? Because
Yes.
if you don't apply a force, it just stay over there. But if you apply a force, you can just go with it. In neutral. In neutral about it. In nonchalant. Right? So this is a nonchalant guy. Isaiah, are you a nonchalant guy? I didn't hear.
Really.
Fully?
Yeah.
Isaiah, I have a question for you, right? And you know the nonchalant guy meme,
Yeah.
type shift. You ever see
Yeah.
that?
Yeah. And school.
Oh, I can imagine you saying that. Ladies or ladies say that. I feel like more guys will say that than girls. I ever said that before.
Yeah.
Serious, Shay? Serious?
Yeah.
You're not serious? Okay. Type shift. I can't imagine like you're saying that. I really can't. Okay, so I think I'll understand it now, right? So it's common sense. So Shay, stable means obviously it's stable, right? If you hit it, it probably wouldn't topple over. Unstable means that if you hit it, it will definitely fall over. Neutral means that it wouldn't resist it, it would just go with it. So great. I would like you all to now copy down this and draw the diagram as well. So Isaiah, I had to ask you, which class more vibes? Is it the maths class, art maths class, or the physics class?
Physics and maths and maths.
When you say all, I ask you which one is the most vibes?
Physics first.
Physics first. Ladies, what about earlier?
I'd have to say physics first as well.
Physics
Yeah,
first.
probably physics.
Unless still like chemistry over physics.
Yes.
Yes.
Has some serious inertia over there. I don't know what I got to do to convince all the physics better. Don't know what I got to do. It's like all they don't want is like are they resisting any change in priorities? No inertia. That
Chemicals are so fun.
what is so fun?
Chemicals.
You just okay, Walter White. Okay, Walter White. Right. And Shana, why you like chemistry so much as opposed to physics?
I just like chemistry more because physics, the experience with my physics teacher has not been up to par to say that physics is better than chemistry.
Okay, well, I will change that, right? I will change that for sure, for sure. Yeah. Um, I can show you a good couple of examples as to why physics is better than chemistry. A good couple of examples. You know
So
me,
most piss me off.
moles is piss you off.
Yeah.
We have a real easy way to do moles, you know. Like moles, deceptively easy. But I will never teach chemistry because chemistry, I don't like boring. But basically, Isaiah, I want you to think of moles just like algebra. Like maths is the whole reason why I get a distinction in chemistry. Maths is the whole reason why. If it wasn't for maths now, I would have failed chemistry so bad. Yeah, so Isaiah, just think of moles as algebra. And if that might help, just shift your perspective. Change your perspective on it. It will help you. Right? She, I saw that you unmute for a second. Is he was going to say something?
No, the thing hit the spacebar.
Oh, okay. So here, what? When you finish, copy down objects or systems and the diagrams. Send me a picture. Whoever had the best diagram, I'll post all
So you
them.
could laugh at our diagrams.
I'll post all the diagram. I will start.
You will definitely allowed.
I will tag all you. I will tag all you. Whichever one is the best one. Yeah. So okay, we know there's 6 more minutes to finish up everything. I feel like Isaiah going to do the diagram real nice. But you should see Isaiah's physics notes is like peak, a real peak. Isaiah, you just drawing thing by chance?
For school alone.
Oh, okay. I'll ask, ladies, I think I asked you all that already, and I'll just say for school. Hmm. So, 5 minutes. I'm gonna stay quiet, let me copy this down, and then we're gonna move on to the experiment to find the center of gravity for irregular lamina. Well, Shayna, that not bad. That not bad. Well, they have me thinking, I'll get hard as I can think. So, I'm waiting on Isaiah and Shay. Isaiah and Shay, I feel like all the it's either all the real putting effort into the diagram or they making it real bad, so I don't post it up. Yeah. Shay, which one is that?
Honestly, could be both.
Damn. Now I trust I go put effort into your notes and make it look nice, you know? And Isaiah, I feel like you're really taking time to do it.
I'm moving slow today.
Say that again.
I'm moving slow today.
You're moving skillfully.
No, no, see, I'm moving slow today.
Oh, okay, okay. Yeah, because I know normally you just move real fast. Like you and she just be giving each other a competition, but like this time Sheena come ahead. Big up Sheena. Sheena, I guess you need today. Okay, so Isaiah, I'm sure expecting a diagram in 1 minute. Yeah, because we gotta move on. Oh, Isaiah, well, you got through the uh The storage finish. Shit, don't tell me the storage finish too, eh? Okay, look at some maybe. Okay, well, not bad. And Shady, you know what cog means? COG?
Center of gravity.
Okay, cool. Had to test it. All right, so did you all ever do this experiment as yet trying to find a center for um uh, irregular shape? Yeah or no?
No.
That's interesting. Wait, huh? They like to bring this question in the exam. Yeah. So I get back to this, right? But this is the question they like to bring in the exam. Okay, so let me show you how to deal with this. Okay. So Shina, I'd like you to read this part for me about an irregular laminar's center of gravity. Right, so begin. Shina?
Oh, sorry. An irregular laminar center of gravity can be found by boring holes and hanging a plumb line from each hole. The purpose of the plumb line is to see which points are vertically below the hole. By marking the lines, an intersection will be noticed. This is a laminar center of gravity.
So Shina, but from reading that, how much of that do you actually understand? You can be very honest with me.
So I have to just now.
Okay. From reading from hearing that being read, how much of that do you actually understand?
Um, At the points are vertically below the hole.
Okay. Um, you feel like you understand anything of substance there?
No.
See, I like that. I like that. Well, I do like the fact I do understand, but I'll explain it to you better. All right. So Sheena, as soon as you're available again, let me know.
Yes, sir.
Okay, cool. So um you all understand that the whole takeaway from this is see which points are vertically below. So that being said, okay, that being said, I want you all to figure out what is the answer over here. So give this question a read for me. This was from the 2025 paper one for January. So anybody could tell me what they think the answer is. So in an
D2.
you said D?
Mm-hmm.
Yeah, D is the answer. She, understand why D is the answer?
Can
No,
you give a crash course real quick?
not really. Okay, let me here what. Let me actually explain the experimental setup and everything, right? Um, okay, I do have the exact diagram. Give me a moment. I'm gonna get an actual diagram showing you the experimental setup for this diagram, right? And I go explain it. Um, okay, cool. Let me share my screen. Hopefully you guys will understand what's going on. Right. So here we're working, right? If we have an irregular shape, does everybody understand why that would kind of be hard to figure out where the center of gravity is? Yeah or no? Isaiah, you understand that if you have an irregular shape, I'm talking about something that isn't a rectangle, isn't a square, isn't a circle, crazy. Kind of be hard to figure
Yeah.
out the gravity. Okay. She, what about you? You understand that, right?
Yes.
Yeah, so here what we're doing, right? Let me just say we have a shape like this, right? And you want to find the center of gravity. You wouldn't just say the center, right? How you even know that is the center? Right, Shay? Because it's irregular. How you know that is the center? You agree, right?
Yes.
So what we're going to do is we're going to take our retort stand, put it here. We're going to place a pin. We are going to put some holes along the end of the irregular piece of paper, right? Like so. So you all following so far, right? Yeah or no?
Yes, sir.
Okay, cool. And we are going to, what we're going to do is we are going to take we're going to take the piece of paper and we're going to attach it like this. So you all following so far?
Yes, sir.
Yeah, okay. I'm not sure why I'm not annotating. That's weird. Okay, that's really weird. Am I sticking on your end?
No, not really.
Okay, well, it real sticking on my end. Give me a moment. Un momento. Give me a moment. Can you all see my screen? Yeah or no? Wait, I just stopped sharing. Hope the issue gets resolved. Yeah, so are you all seeing my screen?
Yes, sir.
Cool. All right, so all you understand what I said so far, right? You have an irregular shape. Irregular shape. What we're gonna do is we're gonna put a bunch of holes along the outer perimeter, right? So we following so far. Tell me if you understand. She, we good?
Yes, sir.
Nice. So she don't understand. Isaiah, you understand?
Yeah.
And then what we're gonna do is we're gonna take our pin, and you see this hole over here? We're gonna place it. We're gonna place it inside the pin. And we're gonna place the pin inside of the hole, right? So it's gonna like levitate. It's just gonna be there hanging. Could you all visualize that? So like you put it, you take it and you place it. So it's kind of like swaying side to side now. So it's just like it's just down. Could we all visualize that?
Yes.
So then what we're gonna do is we're gonna take a string, right? We're gonna take a string that has a mass on it. And we're going to place that over here. Now, by us placing that string, it would give us a path that is directly what? So tell me, Shay, if imagine you have a string here, right? With a mass attached to it. Where would this string, what kind of path would it create? Would it create a vertical path, a horizontal path? What do you think?
What was the question?
The question was, the question was, if I were to take a string that has a mass attached to it, wouldn't the string experience a downwards force because of the mass attached to it?
Yes. Sorry, I can hear the question before you're sticking for me.
That's okay. And so what kind of path would the string create? A vertical or a horizontal path?
A vertical.
Right, a vertical. And so we take a pencil and we would draw that, right? So you're following so far. Tell me if you're following so far.
Yes, sir.
Okay. So you would do that with this hole, then you would swap it with this one and repeat the same process. And you're doing this until you get us an intersection. And the intersection would be the center of gravity. So you think you understand the experiment better now?
Yes, sir.
Awesome. Right? So this is what would end up happening. Right? And so the point where it intersects, that's the center of gravity. Isaiah, did you notice? Yeah?
Yeah.
Okay, cool. So, and you see this line over here, we call this the plumb line. I don't know why they call it the plumb line, but we call it a plumb line. Plumb line. Sure, let's go back to the question, the multiple choice question, and you should understand it now. So, Shay, give the question a read. Yeah, so Shay, give the question a read for me.
Oh, like we did a lot. Oh, sorry. In an experiment to locate the center of gravity of a sheet of cardboard, a plumb line string with a small mass at the end is used. The plumb line is used to A, check that the apparatus is vertical, B, measure the width of the cardboard, C, check that the cardboard is swinging freely, and D, show which point are vertically below the pivot.
D, right?
D, for sure.
Because you understand that when you hang the thread, it would create points vertically below the pin, right? Which is the pivot. So
Yes, sir.
so yeah, we go with that. Great. Cool. So that's the last thing I'll leave you all to copy down. So this is the last thing I want you all to copy down, and that'll be for class today. So copy this down quickly and that'll be it. Right? In the next class, we're gonna start moments, which is like with rulers on, you pivot, you have to calculate the distance from the pivot. Shay, I believe that's the last thing you did.
Yes.
Like these kind of questions. Shay, now, did you ever attempt any of those questions? Did you start it in school? Tell me.
We didn't start it in school, but I did a couple questions with my sister.
Okay, cool. Oh wait, so Shayna, the person that told you that the question in art maths wasn't correct was the sister.
No, it was my friends who was going into fun life.
Oh, okay, okay. Because if my sister could help you with physics, I'm sure she could help you with art maths. I mean, yeah, art maths. I'm sure.
Yes.
So that's what I thought. But that question was a trick question, right? Root 4 is 2, minus 2 plus 2 is 0. So the whole thing was just going to be 0. When I was given all that question and I came up with it, that is what I had in mind. So yeah, when you finish, copy down an irregular laminar center of gravity can be found by whatever. Send me a picture, and whoever had the best diagram, I'll post all on my status and tag all them. All the parents might feel nice and they might buy something for them. You know? Sure, you might get a Bobby. I know you don't like Bobby. In our Isaiah, all you might get Bobbies too. But I guess not all they like Bobbies either.
So, stay soon.
Isaiah, you like Bobbies?
Yep.
Shana, what about you?
No, Lisa.
I don't like it because it's kind of look like people head. Like, all you ever see a brownie and, I mean, I'm not saying a brownie. All you ever look at a Bobby, right? Another picture, a bald head.
It
Like
looks like my dad's.
it looks, I would say something controversial there, but Rowley head, you know what I mean? Like, like Rowley's head in some angles does look like a bug.
And the sun, it's so shiny in real life.
Yes, yes. I had an art math teacher. His head was so shiny when he came out for assembly, we used to cover our eyes. So bad. Yeah. Isaiah, you know anybody whose back of their head is look like a bobby?
My form she math teacher.
The general consensus is that math teachers bald. I hope I don't get bald. I love my hair. I pray not to go bald. See me?
So I have a question with the diagram,
Yeah,
with the letters. Like, at the bottom one, is it like an apostrophe after the P, R, and Q?
yeah, that is P prime, R prime, and Q prime. Yeah.
Okay.
Wait, that's so I suppose you never did transformations in school as yet in maths.
No, I did, but I was kind of confused on why it was like why is the P prime there, not at like the top, like to match the rest now?
That's because remember when you set it up on the diagram, right? Remember you would make a hole. You'd make a hole, right? So these from what I gather, um okay, I see a confusion, right? Just know that okay, it don't really matter, but you understand that you'd bore a hole, you'd put that in the pin,
Yes, I
uh,
understand the method.
right? And so what confuses me in this diagram is that it don't really have a standard because these small holes, one is P, one is Q prime, one is R prime. Um, but it shouldn't really matter. It shouldn't really matter. But let me just correct it, right? I'll correct it. Let me correct the diagram. It's kind of inconsistent. These aren't my notes, but I use them because they're still good. I have a couple errors in it, but these notes are still good, right? So P, Q, R. So Sheena, if I'm calling this P, what would I make this one? Sheena, if I'm calling this P, what would I make this? Do you know? Okay, Sheena went quiet. Sheena, do you know?
Um,
I will start you off, right? We'll call it P prime. If this is Q, what do you think I'll call this?
Q prime,
Right? And this?
R prime.
Right. Yeah, Shay, I hope you're less confused now. So like all of the small holes, that is like where that's where you would have sticked it into the pin. And the bigger ones are not holes, right? That's like okay, so Shay, remember when I was showing you the experimental setup, right? Do you think it would be stable drawing a line following thread, or does it just make sense to put another, like, okay, at the end of the thread, just put like a dot and then connect the line after? What do you think?
Put the dot on the connected line after.
Yeah, that make a lot more sense, right? Or you just take a pencil and stick a hole through the paper and you connect after, which is what I usually do. Right? Good job, Isaiah. That's the experiment. Yeah. Okay, so I'm waiting for the pictures of the other diagrams from Isaiah and Shayna. Right, so as soon as we done that, that's it for class today. I'm going to give you all some homework. I'm gonna find some past papers and I'll give all you some questions to do based on what we do so far. You know what? I feel like everybody diagram is so nice. It's like it's hard to just choose one person.
I can help you out. I don't think you should choose mine.
Oh, why? But your
Uh,
diagrams. Okay, I wouldn't post yours. All right, Shana, your diagram looks good as well. Something interesting. Check this, right? So I find this really interesting. Check this out. So Shay and Shana, your diagrams are very similar, right? But it's like other flip the colors. So one of you guys use black, and where the other person used black, the other one used orange. And where the other one used orange, the other one used black. Are they sure it's not twins? Because like
no.
I feel I would plan that.
Orange is a universal color for physics.
Serious? I didn't know that. I had to teach physics. I would say is like even I don't know. Probably like a shade of blue.
Definitely not.
What is associated with blue mats?
For me, maths is red.
What? Is it because it makes you angry?
Let's go based on color, the textbook.
Or you sure you're not colorblind? I joking. For me, maths is undisputably blue. Right? Bio is green. Um uh
Bio is blue, geography is green.
nah, bio is green. Sorry to break it to you, bio is green. Yeah. But here it is. I have a bunch of physics and math textbooks. These are the main colors. I see in purple, I see in green, I see in yellow, I see in white. Yeah, Isaiah, I will take a picture. Right? So this is the end of class, but Isaiah wants to do something. So here, Isaiah, you could put on your video. I will take a picture of your dog. Do any of you all have dogs as well?
Nah, I did.
I do.
Okay. That's that's hilarious. Oh, the dog that wants that she doesn't like pictures. Clearly. She's shy. Okay, I got it. Yeah, I got it. Right. So yeah, guys, class today was good. I'll send some past paper questions, right? So see you all next week. I'll see you all next week. It's everybody. Bye
Bye,
bye.
sir.
Yeah, it's everybody.